So this is our first equation, slope-intercept form. We have y equals mx plus b. There you have m as your slope, also known as rate of change, and your b is your y-intercept. And then x and y are your ordered pair. Okay, those are the components of that equation. So we have an example that says write a linear equation in slope-intercept form using the ordered pairs in the table below. First things I like to underline is that the linear equation that they're asking for is slope-intercept form, and that is y equals mx plus b, that given formula, okay? And then they tell us that these are ordered pairs in our table. So a lot of us forget that these are ordered pairs, meaning x and y's. I can choose two from the table and go from there. Any two. I chose for this instance because we need two components, slope and y-intercept. So for slope, we need 2 points. I chose -5, 10, and -1, 2. But you can choose any other two. And if this is a straight line, it should calculate to the same slope. So here we have me calculating slope using the slope formula. Here are the ordered pairs that we are substituting into the formula. As you can see, I crossed them off after I inputted them. I subtract the numbers across, and then I divide the numbers up and down. And here we go, my final answer, m equals -2. So we're writing an equation in slope-intercept form, so we need those two components, m and b. So we found the m, now it's time for us to find the b. So I'm gonna try to do this in step-by-step since it's already solved. So our slope-intercept form needs a y-intercept, which is our b value. Here. So we already have a y, we have an m, we have an x, because an x and a y is an ordered pair. And I chose an ordered pair from the table, 3, -6. But we need the b value. So that's like our missing value. So we're kind of going to use our solving for unknown values strategy here. So we know the m is -2. We know the x and y is an ordered pair, but we don't know b. So we're going to take that equation and we're going to substitute those values for y, m, and x, leaving b out of the we don't know yet. It's unknown. We solve for those values, so simplifying the numbers, performing the inverse on both sides, and then in this instance, our b value equals 0. It could equal 88. It could equal 112. It could equal -0.2. Whatever that b value is, we box that up. And then we take it to our final answer. So it's asking for, again, an equation in slope-intercept form. So we got the parts, but our answer is not complete until we write it in its final answer. In its format, which is y equals mx plus b, m being our slope, -2, b being our y-intercept that we got was 0. 0 is an imaginary number, literally imaginary as in doesn't exist. So we can say that our final answer is just y equals -2x. All right. So I have a practice example for you all to do on this one. I'm going to just zoom that out a little bit so some of us can pause that and get the answer out. So here is your example for this problem. So I give you another table, write linear equation in slope-intercept form using ordered pairs in the table below. And there are your ordered pairs in the table. Okay? And then you pause here and you solve it using the strategies below. And then hopefully once you have solved it towards mastery, doing it as many times as you can until you get the answer, your answer should be y equals -3x minus 4. Okay? And then we're going to move into our point slope form next. So here we have the point slope formula. Y minus y1 equals mx minus x1. This is just a not simplified slope-intercept form equation. Still has the y, has the m, has the x. There's technically no plus b in this part until we use distribution, and then we'll see a plus b. So anyway, there are two components to point slope form, the point and the slope. Having an x and a y value, that goes here, where x1 and y1. And then we also need to have that slope, point slope formula. So those three values we need to have in order to use this equation. So we have an example here. Write equation and point slope formula given the point 2,5 and the slope of the line is 0.8. So I'm going to write out what we were given real quick. So my point is 2, 5, and that is an x and a y. And then the slope that we were given, we know slope is for the variable m, and it is 0.8. Now some are saying, oh, miss, it's a decimal, huh? We can keep it as a decimal, or we can also turn it into a fraction using our calculators, or asking the Google to turn it into a fraction, and that fraction is 4/5. Okay, so you can have either or. Okay, so now that we have the two components that we need in order to use point slope formula, point and the slope, we can simply just use the equation, which is y minus y1 equals the m times x minus x1. Okay, so one meaning we only need 1 point. If they were given multiple points, we could choose from that 1 point. So we're gonna keep our y, but we're gonna again substitute, just like I have here, the highlighted values that we're looking for. Y1, which is going to be 5, equals m, which is our slope, so we can put 0.8 or 4/5. I'm a fractions type girl, so I'm going to use the fraction x, and then our minus, instead of x1, that is the x value in our point, which is 2. Okay, now we're just going to drop some of those parentheses. So this is going to end up being y minus 5 equals 4/5, parentheses x minus 2. And that, simply put, is your linear equation written in point slope formula. There's your slope. There is your x and y point. Okay? All right. All right, now given another example, going back to the first example with slope-intercept form using that table. So let's say that we were given a table, or you can do this with the previous example from that same section. Let's say we were given a table, right, and we were told to write in point slope formula. Make sure that we remember the two components that we need in order to write an equation in point slope formula. We need a point, which is an x and y value, and we need a slope, which is our m value, okay? Once we have those two things, we can simply write this equation in point slope formula. Simply as that. So think about that when it comes to a table. What two components, how can we get these two components given a table of ordered pairs, okay? I'm going to write the correct answer here. That is my answer. Now, before you erase your answer and you say it's wrong, you think, oh my God, Miss Snow, like, why didn't I get the same thing? The points are going to vary, right? Because we had multiple points in our table. This is still going to be our simplified answer because we used a point from the graph and the correct slope. If we simplify this out and go just above and solve it for slope-intercept form, you'll see that it's the same equation. If we solve just for y, and you can go back to our previous equation that we found in the beginning. So don't get caught up on that part as long as you have a point. So as long as you have an x and a y here and you have the correct slope, your answer is correct. Cool. All right, so let's move on to the last one. All right, y'all, last part, standard form. So standard form equation is ax plus by equals c. This is basically saying this is like the original way some equations might come. It's the standard way of seeing a linear equation until we convert it into slope-intercept form or use point-slope formula. So just a quick way to write an equation in slope-intercept form. If we're given an equation like y equals 3 over 4x minus 6, and we're asked to write in standard form, what they're asking us to do is eventually have our answer looking like ax plus by equals c. And our equation start off as y equals 3 over 4x minus 6. And we know this to be slope-intercept form, which is y equals mx plus b. So some similarities, we see that they both have y. We see that they both have x. Not necessarily the m and the b, but the similarities are that there are x and y. So we're going to get this equation to convert from here to here. Okay. So basically, when we solved for y, seeing as you see y is tucked into this equation, when we used to solve from here to here, we would move the x term over, and then we would divide by the term that was in front of y. That's technically how we got this equation, okay? And I'll show that on the back end. So to undo that necessarily and to put all of those numbers back in front of the variables, we're going to undo the division that happened in order to get y by itself. So I have my equation y equals 3 over 4x minus 6, okay? If we all remember the strategy, we divided by 4 essentially in order to get this fraction. Like we had to divide something by 4 to simplify to 3 over 4, which means we also divided whatever this number was by 4 in order to get negative 6. And we also divided this term by 4 in order to get the y by itself. So the inverse of that, and I'm actually going to use this pen, is to multiply the entire equation, and I'm going to use a dot for it, times 4. And you can put the 4 on any side. So therefore, we're kind of using distributive property for this 4, multiplying it by everything in the parentheses. Okay, and I'm running out of room. So that's going to turn into 4y, hope y'all can still see that, equals 4 times 3 over 4x, 12 divided by 4. That's 3x, and you can use your calculator for that, in case you don't know that. And then negative 24, right? Now, as we can see, our equation is getting really, really similar to standard form, ax plus by equals c. But we need that ax term, that term with the x value, to be in the front. And we need that c term to be on the opposite side of the equal sign by itself. And right now, our crooked little c term is right there. So that means I need to move my 3x term. Remember, if we have that wall on our equal sign, we can only perform the inverse, which is minus 3x on both sides. Okay? These are not like terms, so we cannot combine them. So I'm going to bring that work over here, crossing these out. So I'm going to put the mx term first, or the ax term in this part, plus 4y equals negative 24. And that is our equation in standard form. Again, we did the inverse of the dividing, and then we moved the m term, or the ax term. So this is now ax plus by equals c. Okay. No, that was a little fast. Pardon me on the camera thing. Again, rewind it, take your time and go back, watch it again, and I'm going to post another example for you to do and the answer. All right, y'all, so this video is choppy, but we're getting through it. So, you know, I don't like to leave problems out without having to check and trying to connect it all back together. So remember that we're writing 3 different equations for the same scenario, so that all these equations should be equivalent. Your point slope formula should be equivalent to your slope intercept form, which should be equivalent to your standard form. So we want to make sure. So we are, again, familiar with solving for y, so I'm simply going to do the inverse on both sides in order to get this y by itself. Please watch how my work is staying neat. Again, remember, we do not combine terms that are not alike. And then there it is. We divided all of these terms by 4. That's why we multiplied the terms by 4 and That definitely looks like the equation we started off with right there. So we know we did it right. Awesome. So here's your practice problem. Given y equals -1/3x plus 8, write the equation in standard form. Remember that the question is asking you to write it in standard form, so you know that your final answer needs to be ax plus by equals c in this part. Okay, the answer is coming soon. Stay tuned. You can pause or keep watching. So the answer I got is 1x plus 3y equals 24. And then I always do the check just to make sure I got the right answer. Boom.